Hey, algebra students. This is Mrs. Charlie, and we're going to start actually learning some new algebra. And actually, I say new, but it's actually some review. So we're going to start out with Unit 1, which is pre-algebra skills. Yes, these things should look familiar to you. They should be something that you have seen last year. So what I'm going to do is go through the notes, and what I'd like you to do is follow along at the same time. So you might need to do a split screen, or if you have two devices, that might work out well. You can use the markup tool for your PDF on your iPad, and maybe you can watch this video on your phone or something like that, or you can do a split screen. You guys know all about those things. So Unit 1, pre-algebra skills. So our first lesson is comparing and ordering numbers. And yes, this is something that you've already done. So let's talk about rational versus irrational numbers. A rational number, and this is what you're going to write in, can be written as a fraction. And what do I mean by that? I mean, it can be nice and neat. So 1/2 is a rational number, it's a fraction. 6 is a rational number, can be written as a fraction, 6/1. 22/7, that's as close to pi as we get with a fraction. 4, well, that's not a 4. How about 6.77777 repeating? If you have a repeating decimal like that, that's also considered a rational number. So any of these fractions or decimals that are repeating, if there's a nice neat pattern, well, that's a 3, 3.4646, rational number. An irrational number cannot be written as a fraction. Written as a fraction. Need to work on my handwriting, I guess, huh? Cannot be written as a fraction. They're messy decimals, and they don't end, and they are not repeating. So something like pi, which is 3.14159, and there's no pattern there, it doesn't repeat. So pi is probably one of the most common ones. E is an irrational number. It's 2.7, and I forget the rest of them, 136, but if there's no pattern there in those decimal numbers, that's considered irrational. The other time you see it often is in square roots, so square root of 2, square root of 3, square root of 7, those are all considered irrational. So I found a little comic and put it in your notes. Don't you think you guys should stop fighting? You're both being irrational. And that's because pi is irrational, the square root of 2 is irrational, but 8 is considered rational. So a little bit cheesy, but there it is. So example 1, what you can do is use your calculator if you get stuck. I have a picture up here of the kind of calculator that I hope you have. They're available at Walmart and Target and Amazon, Staples, any of those places. Or you can use your iPad. Somebody asked me to use my phone. Yeah, you can use your phone for now while we're remote learning, but when we get to the Keystone exams, we can't use our phone. I can't find my little yellow calculator tonight, so I've got my big giant calculator. This also works. We want to classify each number as rational or irrational. So the number 7 here, pick a new color, something interesting to look at. Because it can be written as a fraction, this is rational. The square root of 16, you want to try to simplify as much as you can. The square root of 16, if you put that in your calculator, is 4, also rational. Negative 1.6 repeating is negative 1.6, and that means 6666666. So because that continues forever and ever and ever in a pattern, this one's rational. 5% as a decimal is 0.05, rational. 3/7 is already a fraction, rational. Now I see negative square root of 28. So I want to ask myself, does that square root of 28 simplify at all? It's not a perfect square that I can think of. So I'm going to use my calculator and double check. Square root of 28 is 5.2915. And I know that's teeny, teeny, tiny for you guys. It might even be backwards. But 5.2915026. And it doesn't repeat. It's really messy. This one's irrational. irrational. So not so nice to look at, irrational, that messy, messy, messy list of numbers. All the other ones are nice and neat. Those are considered rational. Ordering numbers, what does each symbol mean? I know you've seen these ever since elementary school. You've seen these for a long, long, long time. That first one, as a reminder, is greater than. The next one, as a reminder, is less than. And we all know the last one is equal to. There you go, just a nice little reminder. So we're going to compare some numbers. We're going to cruise on through these. We want to compare each set of numbers with less than, greater than, or equal to. So -8 and -7.6. I wish we were in my classroom. I have a number line above the whiteboard, and I'd point to the -8 and I'd point to the -7.6. And you would see that -8 is to the left. That makes it smaller than -7.6. The -7.6 is actually bigger. So what's bigger, 2.121 or 2.1? The easiest thing to do is add a few extra zeros on here. So we have 3 decimal places and 3 decimal places. Now you compare. 2.121 is larger than 2.1. This one, decimals are easier to compare. So 2 3/4 is really 2.75. And this is 2.75. Those are equal. 1.3 now. 1 1/3 is not 1.3, but it's 1.33333, and that keeps going and going and going. 1.3, you can put zeros on there to fill in those spaces. It's actually a less than. 1.3 is less than 1 1/3. And these decimals again, and negatives. -3.2 and a -3.21. If I compare this and put a 0 here, so here's 2 decimal places. And here's 2 decimal places. The one on the left, this -3.2, is actually bigger. When you get to those negative numbers, remember they go backwards. So here's a -4, -3, -2, -1, 0, and 1. Your -3.20 is somewhere over here, and -3.21 would be a little bit to the left. I just did that backwards. No, I didn't. We're good. We're good. Okay, this one's greater. Late at night, I'm second guessing myself. Probably not too late for you guys. What we need to do in this set is order these from least to greatest. So those smaller numbers, again, I wish we had that number line in front of us. Your negative numbers are going to come first. -8, then -6. Check those off our list. Sorry, my pencil fell. Then we hit a 0. And then we have our positive numbers. I see a 2, a 3, and a 6 that are left. There we go, least to greatest. For the next set, letter B, we have to get a little bit tougher. We're in Algebra 1 now. You want to make these into decimals. So 4.5 is really 4.5. The next one is 4.55, -4, and -4.23. Remember, those negative numbers are going to come first. So -4.2334, comma, -4, comma, 4.5 is smaller than 4.55, but you want the original form, 4.5, and then 4.55. There you go, least to greatest. Example 4. Now, you got to make sure you read the directions because sometimes they switch the order on us, which is what happened here. We want greatest to least, so we want the largest number. So my positives are going to come before my negatives. And again, you want to compare decimals. So 8 1/5 is really 8.2, and then 8.15. So the biggest one on this list is 8 1/5, 8.15, and then I get into my negatives. -6.9 and -6 7/8. I always forget my 7/8 decimal. 8.875, so -6.875. So the next biggest is -6 7/8, and then the smallest is -6.9. On this list, this is a fraction, so this is -0.3 repeating, that -1/3. The biggest number, and these are all negatives, so furthest to the right is -1/3. The next biggest is -1. negative 13, and negative 13.1. So there you go. If you get a little stuck on the fractions, no big deal. I'm a math teacher and I just got stuck on a fraction. Remember to use your calculator. And so I covered up my note here. Use your calculator, turn them into decimals. So pause your video right here. Take a second, try these 4 problems all by yourself. Then come back and compare your answers. So take a second, use your calculator, and then come check your answers. There you go, just like that magic, the answers are there. Go ahead and check your work compared to mine. Just watch the instructions, because I fall guilty to this as well, where I don't read carefully. So for number 1, order the numbers from greatest to least. So you want the largest numbers and then the smallest ones. So I started with the biggest, which is 6, all the way down to the smallest, which is negative 10. The biggest, which is 12, all the way down to the smallest, which is negative 8. And then on the other side, the directions are a little bit different. Least to greatest, so the smallest number is negative 5, all the way up to 8. The smallest number is negative 5 2/3, all the way up to 16. So just make sure that you're reading the instructions on those. All right, example 5. More fractions, more decimals, least to greatest. So the smallest number on our list, we don't have to deal with negatives, is 8. This one's 8.5. The middle one is 8.5 repeating, so lots of 5s. 8 1/5 is really 8.2. And 8 3/4 is 8.75. So least to greatest. 8 is the smallest on that list. The next one is 8.2, which is really 8 1/5. Let me erase these. 8 we got. 8 1/5, which is really that 8.2, which is all done. 8.5, 8.5 repeating, and 8.75. So here's a trick if you're a little stuck. I know this is going to be really easy for some of you, and some of you might be a little bit stuck. Think of it like money. Think of 2 decimal points. $8.75 is a little bit more than $8.55, which is a little bit more than $8.50, which is a little bit more than $8.20, which is more than $8. So if I get stuck, I think of them like money. Letter B, we have a bunch of negative numbers, so you want to be careful with those. We want to put an order from greatest to least. So the biggest one on here is negative 4. And let's see, negative 4 2/3, this is really negative 4.6 repeating. Again, if you're not sure what that is, use your calculator. The next biggest is negative 4.23. The next largest is negative 4.5. And then the smallest is negative 4.6 repeating, negative 4 2/3. All right, there you go. All right, same idea. Pause your video here if you need to. Go ahead, put them in order. Number 1 is greatest to least, and number 2 is least to greatest. Go ahead, try those, and we'll compare answers in a second. All right, there we go. These are my solutions. So again, you just want to watch the instructions. For number 1, we want greatest to least. These are a little bit tougher than the last set. Turn those fractions into decimals. That's what I did here. And you want to go from the largest all the way to the smallest. Again, turn these fractions into decimals and go from the largest number to the smallest. The negative numbers, remember, are reversed. For number 2, we want to go from least to greatest. So these are the smallest numbers to the largest. So smallest is 5.5 all the way up to 5.75. Again, turn those fractions into decimals. Use your calculator, totally fine. I turn all my fractions into decimals, and you want to go least to greatest. These are smallest, and these are largest. All right, example 6A. You want to place each number at the appropriate spot on the number line. So I've been talking about number lines. All you got to do is plot these. No big deal. Here's negative 5. Here's our 2. Here's negative 5.5. And here's 3. That's all I'm looking for. Just draw dots on the number line, easy peasy. For example, 6b, same idea. I mixed it up just a little bit on you. 3 over 2, you want to turn into a decimal as 1.5. 2 squared, you want to turn into a decimal as 4. So 1.5 is right here. This is our 3 halves. It's probably a good idea to label them. 4 is really 2 squared. 2.2 is a little bit bigger than 2. And negative 2 is all the way over here on the left. Okay, again, decimals. Decimals are your friends. So I'm going to pull my calculator out. Remember, I have my big one tonight. 3 times pi divided by 2 is, this one's really 4.7. Let's get some new colors. 4.712. The square root of 4 I know is 2. Pi, just because I use it all the time, is 3.14159. The square root of 9/16, this is really 3/4, which is really 0.75. So then I have to put them on the number line. So 4.7 I know is between 4 and 5, a little bit closer to the 5. So over here is 3 pi over 2. The square root of 4 is really 2, so it's really here. Pi is 3.14. And 0.75 is right here. It's square root of 9/16. There you go. So they get a little bit tougher as we get down the examples. Same thing, we want to turn these into decimals again, 1 3/7. I'm just going to do the divide by 7 piece. So this is 1.43. The next one is negative 4.5 repeating. 6 times pi divided by 2. That's really 3 pi. So this one is 9.42. The square root of 25, maybe you already know, is 5. And the square root of 17, I have no idea. So I'm going to put that on my calculator. And I've got 4.123. Again, just pop these on the number line. So 1.43 is between 1 and 2. So there's my 1 3/7. Negative 4.5 repeating is over here. Negative 4 5/9. 6 pi over 2, 9.42 is over here. So this is 6 pi over 2. Square root of 25 is right here. And square root of 17 is 4.123. So this is the square root of 17. Place them on a number line. You guys can do this. Keep going. 2.5 is right here. 3.5 is down here. Those are easy peasy, ready to go. Negative 2.2 is right here. And negative 30 over 6, this is really a division problem. Negative 30 divided by 6 is negative 5. So this is right here. Negative 30 over 6. All right. F, lots more of these. Use your calculator. The only one I know on this list for certain is the square root of 25. The square root of 25 is 5. The square root of 39. On your calculator, you probably have to use a second function button. Mine's blue. Yours is probably just offset by a different color. I know you may not have this giant calculator, but it probably says second function. So the square root of 39 is 6.24. Pi divided by 3 is 1.05. And 23 divided by 4 is 5.75. So again, graph these on the number line between 6 and 7. This is square root of 39. Here's your square root of 25. A little bit bigger than 1 is pi over 3. And 5.75 is right in here. This is your 23 over 4. All right, I've got 2 for you to try. So pause your video here. Try to put these on the number line. And again, we'll compare notes in just a sec. All right, there we go. I didn't label them on the number line specifically this time, but you should be able to match these up pretty well. For example, A, those are where my points lie. all the way through here. And for part B, my points are all over here. So there you go. Compare your answers. Example 7, I like these a little bit better. Use the number line to match each question. Instead of just plotting the points, they're not going to actually ask you to do that in the Keystone exam. They'll have points for you. So which dot matches the square root of 9? Well, the square root of 9 is equal to 3. So which dot is at 3? It's C. For letter B, which dot is closest to -3? Now, if you notice, there's not a value directly on -3, but which one is closest to -3? Well, I'd say that's the -4 dot A. Example 8, match each dot A, B, and C with the square root of 37, the square root of 42, and the square root of 24. So again, that calculator, you're gonna want one nearby. The square root of 37 is 6.08. The square root of 42 is 6.48. And the square root of 24 in my calculator is 4.89. That would actually round up to 4.90, but that's close enough. So I put them in my calculator. So I'm saying that 4.89, this one's A, 6.48, we have a typo, that's right. I forgot we were supposed to fix the typo on this one and we didn't. B is just a little bit bigger than 6, so this one's your B. This one, unfortunately, is not C. It doesn't match. This looks like C should be 7.5 and it's not. So this one is not there. So you don't have to worry about that one. It doesn't match. Example 9, which dot is the square root of 50? So in my calculator, the square root of 50 is 7.07. So 7.07. So a little bit bigger than 7, that's my point B. B. And again, use your calculator if you need to. Which dot is at 3 pi? Use the calculator again. You want to figure out what 3 pi is. 3 pi is 9.42. I'm looking on my list, 9.42 is C, it's right there. And 3 for you to try. So I'm going to pause my video. You pause your video, give it a try, and then we'll compare in a second. All right, so here we go. Let's compare some answers. I used my calculator, put them all in. The square root of 37 is 6.08, so this is where I made my dot. The square root of 87 I figured out is 9.32, so closest to that is point B. And then on letter C, I took all of those, turned them into decimals, and got what was closest. So I got the square root of 30 was A, the square root of 40 was B, and the square root of 56 was C. And I kind of think that's it. Yep, there we go. That's the bottom of our slides. So what I have for you is a practice worksheet. It's a PDF. If you have access to a printer and want to print it out and write on it, you're welcome to do that. You are welcome to write on notebook paper or printer paper and just take a picture of that to submit to Google Classroom. But this is how you're going to do your homework for me. Even if we were in class together, you take a picture of your homework and upload it to Google Classroom. You can also mark up a PDF, which is what I'm assuming most of you will do. So you are going to try lesson 1, practice 1 after our notes today. Submit a copy of your notes for points. Submit a copy of practice number 1 for points. We want to make sure that you're getting those good grades. If you have any questions, I will be on Zoom to answer your questions, and you can also email me. So nice to see you. Good luck, guys.